Record. Share screen. Thank you for the reminders. You guys are awesome. And today is not the 11th month. Boy, what a fail. Today is 10/16. Today is 10/16, and in answer to your question of what should I call these notes, I'm so sorry. I just started rolling right in there. What you're learning today is a process called synthetic division. Sorry about that. But now I am recording, I think. Let's see, let's make sure. I am recording and I'm screen sharing, so this is good. So yeah, before we learn synthetic division, I want to do another example of long division, just so that when I teach you synthetic division, you'll be like, whoa. But that whoa can't happen unless we do this first. So here we go. So we are taking x plus 7 and we are dividing it into 2x to the 4th plus 16x to the 3rd plus 11x squared minus 23x minus 14. I wanted to give you a problem to start that had no trickeration. There's no missing terms, no zeros necessary. In fact, there just might, hint, hint, wink, wink, not even be a remainder. So let's see what happens here. So remember, this is what you just took a quiz over. And so sorry if I go a little fast, but you guys can help me. What's going to go first right up here? 2x cubed, right? Yes. Because we're trying to make an exact copy of what we see inside the division. And now we're going to multiply. And as we multiply, we will commit to an answer and then quickly change the sign, right? So as I multiply through, I say I would get 2x to the 4th. I'm going to write minus 2x to the 4th. And on the next one, I would get 14x to the 3rd. I'm going to write minus 14x to the 3rd. And then I'm going to add these together, cancel them out. How many x to the 3rds will I have left? I will have 2x to the 3rds, and I will drop down my plus 11x squared, and I shall start again. What now do I add up to the red part? Plus 2x squared. Again, my intention being I want to make an exact copy of the first thing I see inside the division sign. And now when I multiply, I commit and then change the sign. So for my first one, I would get 2x to the 3rd. I'm going to write minus 2x to the 3rd. My second one, I would get plus 14x squared. I'm going to write minus 14x squared. And here we go again. When we add these together, we're going to cross these ones out, and then we're going to bring some stuff down. We're going to bring down, how many x squareds is that? Negative 3x squareds. And then we're going to drop down the minus 23x. And here we go again. So what's the new addition to the red thing up there at the top? I need negative 3x's more. And then I multiply. I am going somewhere with this, I promise. Cross my heart. Multiply, commit, change the sign. I would get minus 3x squared. I write plus 3x squared. I would get minus 21x. I write plus 21x. And then I add, cancel. How many x's do I get? I get negative 2. And then I bring down the negative 14. And again, for the 4th time probably now, I ask myself, what has to go up into the red thing? I need a minus 2 or a negative 2. You can call it whichever one you like better. Because that's what would make the cloned version of the negative 2x is, well, I need to make another negative 2x. And as I multiply the red thing down through the outside, I say to myself, what would I get? But don't write that down, write the opposite. So I would get minus 2x, I write plus 2x. I would get minus 14, I write plus 14. And then when I add these together as advertised, I get no remainder. Therefore, the answer is in this red box. And I really want you to highlight in your notes this red box because we're going to do this problem again. But we're going to do it the awesome way. Nope. The synthetic way. So here we go. Woo! That's what happens when you think you have the hand tool. Not really. Yeah. Yeah. Were you just looking at the clock?
No. Kind of, maybe, yeah. Don't you love her? She's the truth.
I do like the truth. But I wish you wouldn't look at the clock when there's still 40 minutes of class left. It's like, am I hurting you that bad?
No.
You should write this down again because we're about to do the exact same problem, but a way cooler way. You should write this down again.
So do I write it like the structure of?
You should just write it down just like I have it on the board. You should copy down exactly what's up at the top of the television screen. Now I'm going to teach you synthetic division and you're going to like it. I'm not trying to like brainwash you. I'm telling you, you're going to like it. I'm predicting the future. So watch what I'm about to do. Be a part of this. I'm going to take these numbers and don't write them down until you're ready to figure out why I did what I did. Just wait. So let's talk about this. First off, where in the ever-loving daylights did I get 2, 16, 11, negative 23, and negative 14? Where did I get them from?
From the base problem.
From right here. 2, 16, 11, negative 23, negative 14. Because with synthetic division, we don't have to worry about their exponents. We don't have to ever talk about x's for like the next 2 minutes. We just take the numbers, those are called the coefficients. You pluck them off the front of the dividend, the first polynomial, and you just copy them down, flush them down. You should write this down. Once you understand where those numbers came from, write them down. That's another question. We're ready for that question. Okay, Mr. Ahern, I see where you got 2, 16, 11, negative 23, negative 14. Fine, I see it. You circled them in yellow, for God's sake. The follow-up question is, where did I get negative 7? Well, look at this purple. Yeah, nope, that's the wrong color. Look at this purple box over here. It's the opposite. In other words, if you put negative 7, look at my purple arrow, look closely right there. If right at the end of that purple arrow, if I change that x into negative 7, what would negative 7 plus 7 be?
0.
And that's what we're trying to do. So yes, it comes down, Diedrich, to just taking the opposite. So since it says x plus 7, I thought, oh, a negative 7 will turn you opposite. That's what I'm going to use. Now comes the easy part. So what we're about to do is, this is going to blow your mind. This, oh, where are you going, you little turkey? You remember this thing we just did, all this red, white, and purple stuff? We're about to do that, but we're going to do it a lot quicker. So you ready? Here it goes. Step 1. Drop the 2. Step 2. See my purple number on the outside, negative 7? See the red number down below, positive 2? Multiply those. What do you get? So I'm going to stick negative 14 right there. Now I'm going to add the column of numbers that you see, the white and the red numbers, and this is where things can get a little hairy if your basic skills are a little ghetto-y. So what is 16 plus negative 14? It is positive 2. So I'm going to write positive 2 right here, and we're going to start over again. You remember the purple number out front? Now we're going to take Green, follow green circles. Take this times this. What is green circle times green circle? So I'm going to put another negative 14 back into the, right here. Do you remember what we did last time with the stacked white and red numbers? What did we do? What did we do? We added them together. So what is 11 plus a negative 14 or 11 minus 14? So now I'm going to put a negative 3 right down here. What do you think we do now? We take this green times this green. I just keep repeating the same algorithm. What is negative 7 times negative 3? See, if you say negative 21, we're going to have troubles. It is positive 21. Stick it right there, and let's add them together again. What is negative 23 plus 21? Stick a negative 2 here. And hey, guess what we do again? Take that green circle times that green circle. What do you get? Positive 14. So I'm going to stick a positive 14 right here. And hey, guess what we do now? We add those together and we get our remainder of 0. Now, you might be wondering what just happened. Like, I kind of followed your steps, Mr. Ahern, but what the hell are you talking about? Well, here's what I'm talking about. Go back and look at your answer to the problem we just did. What was the first term? What was the first term in our answer? What was it? It was 2x to the third. What was the second term in our answer? Wait a second. So it was plus 2 more x to the seconds. What was the third term in our answer? What? And what was the last term? Hot dog. Now, you cannot deny me that that's pretty cool. Look at that purple number matches that purple number. This purple number matches this purple number. This purple number matches this purple number. And this matches this. Now, you might want to ask the question of how did I know when I, by the way, look at my answer. It just popped right out. There it is. Boom, done. How would I know to write 2x to the third? Well, I know that because remember what the problem started as was x to the fourth, right? You remember that? So when you do a layer of synthetic division, you just peel one layer off the exponent. So x to the fourth drops down to become x to the third. Now, yep. I don't know what just happened. Oh, that was awesome, dude. Let's go again. Round 2. We're not doing this one the long way. We're done. So copy this down. It's important that you get the actual problem copied into your notes or your notes will be utterly useless. So copy down exactly what I'm putting on the television. Do not bypass. Or you'll look at it someday and it'll be like, that does me no good. Trust me. If we did this as a polynomial long division problem, like your quizzes proved to me that most of you still wouldn't have any issue with that. It would be a little bit of a pain, but we're good. Let's do this synthetically. 1. So here come the numbers that I'm going to stack across. I'm going to put 1. What comes after 1? What comes after 8? Negative 15. What comes after that? Negative 10. And in case you're wondering, where did the 1 come from? It came from right in front of x to the third. It was there. And then we're going to draw. Yes. Good job. We're going to do our upside down division sign like this. Upside down house. And out front we put, because that's the opposite of what's the divisor. Now, remember the algorithm. You go like this. You go drop, times, add, times, add, times, add. And you make hopefully 0 mistakes. Here we go. Step 1, drop the 1, zoop, right down below the upside down house. And now multiply. What's 2 times 1? What's 8 plus 2? What's 2 times 10? What's negative 15 plus 20? Positive 5. What's 2 times 5? 10. Add negative 10 plus 10. The remainder is 0. So the question becomes, and yes, by the way, you just divided two polynomials and it took like 19 seconds. Pretty dope, right? The question becomes, well, how do I express the answer? Well, let's take a good clean look at this. The problem started out with x to the 3. If we peel one layer down off of that, what's the first layer going to be in our answer? Yes. So we have 1x squared plus what? Plus 10x plus what? And since there's no remainder, that's the answer.
But you're telling me that I could have taken the test.
I'm telling you that there comes the moment where you get all upset with me that I didn't show you this. This is massively situational. So since I sense a little pouty party coming, here it goes. I'm going to tell you this right now. This kind of division only works under very select circumstances, the kind that we use a lot more in Algebra 2 and beyond. And that is, these are very simple linear binomials that are the divisors. So if you were to look back over your quiz, the only problem on the quiz that you realistically could have even maybe used it for would have been the very first problem. If you tried it on any other, it would have been an absolute. You can't have exponents and you don't even want it to have. Right. Well, it's funny that you would ask. Can you shut the door, please, Diedrich? So that we don't have to listen to whatever else goes on around this place. Thanks. Next problem. If all polynomial division could be done this way, you can totally rest assured I never would have shown you the other way. You have my word. Yes, so the divisor, here's what the divisor can't look like. Maybe I don't think what I said probably made any sense. This would be something the divisor could not be. If you saw a problem that said like this, synthetic division will not work because it has an x squared. If you saw something that said like this, synthetic division can work, but you would have to put a 5/4 on the outside and you better be really good at fractions. So like Diedrich said, it's very situational. That was a perfect word to use there, Diedrich. Got it? All right. All right, let's get to it. Let's stack our numbers across the top. What are they going to be? 3. Yep. And what's going to go on the outside of, nice job. By the way, I'm not going to give you any problems today that are not synthetically dividable. Like, I'm not going to toy with you. So all the problems we're going to do for the rest of the notes and in the assignment are all perfect for synthetic. Just FYI. So here we go. Step 1. Yeah. Step 2. What do we get? -6. Next step. Add them together. Take the white red column right here. What's 2 plus -6? Stick that there. Next step. Multiply. What's -2 times -4? +8. Next step. Add. -11 plus 8. It's not 3. It's -3. Then say it. What is -2 times -3? It is not -6. It's +6. And what's -4 plus 6? It is +2. You'll notice this time that we do have a remainder, and that's okay. So we're going to still do what we've always done. We're still going to write our answer as quotient plus remainder over divisor. Let's get to it. So what is the quotient part of this going to be? 3x to the second minus 4x minus 3 plus a fraction. What goes on top of the fraction? Remainder, 2. What goes on bottom of the fraction? Divisor, x plus 2. Game over. Done. Put it like right there. That's fine. Yeah, totally. I box it because that's how my brain sees the separation between like quotient and remainder. So whatever. Sure. Yeah, man, whatever. Let's go again. And I'm going to start messing with you here soon, but I don't think this is a mess with you problem. So we're keeping it normal here for the first few. Once again, time to set up your numbers, set up your upside down house, and get ready to roll up your sleeves and not make little mistakes. Let's do it. What numbers go across the top? 4, -5, -7, +6, upside down house, number on the outside, and we begin. Drop, multiply, add, multiply, add, multiply, add. You just go until you run out of stuff to do. So step 1 is get that 4 down there, and here we go. First answer. Next answer. Good job. Next answer. Multiply. Purple by new red. What do you get? You get -1. And then when we add those, what do we get? We get -8. Next step. We multiply purple by new red. What's purple times new red? Add, what do we get? And that should be boxed up so that it will help you. Either do it like Micah does and put an R, or box it. That box is essential because it really creates the separation between quotient and remainder. So what is part 1 of my answer? 4x squared minus 1x minus 8 plus a fraction. And what goes on top? Isn't this wonderful? Okay. Next one. Just about the time you think you're rolling, then I go mess with you. So watch out, because I'm going to try to trick you on this one. So you can fall for it or not. That's a 7, by the way. Just got hit with the ugly stick. Tough knows, because he's obviously done this at some points in his life. A lot of us, though, might just cruise right in and go, oh, watch out. What numbers are we going to put across the top? 1, 0.
Why did you get a 0?
Because right here, this should, if we have this set up the way it's supposed to be set up, then right here, there would be a plus 0x squared. Because remember, we want our exponents to go 3, 2, 1, 0. So if it doesn't do that, we fill the gaps with zeros. Good, good. All right. Now let's build our little upside down division house. And what number goes on the outside?
+2.
+2. And we do the process again. And you'll be really fast at this once you're ready to be. You just go drop times add times add. What's first?
1.
Next. Next.
0.
Add. 2. Next. Multiply.
4.
4. Next. Add. Multiply next. Add. Next answer. The remainder is -7. Box it up. So what is the answer to this problem?
X cubed.
What? It started out as x cubed. It drops to x squared. Keep going. Next one.
2x squared.
Whatever these ones were. So like this one was.
So it loses an exponent.
Yes, everything does. So this was x to the 3. This was x to the 2. This was x. Everything goes down 1.
Sorry.
You did.
Key information. Cool. Anyway.
Next one.
Then it's just going to be +10.
Plus 2x.
Oh.
Plus 10. Plus.
Plus -7.
Over
X squared. No, not x squared. -2. Sorry, the exponents confused me.
You're fine. You're fine. Tenemos que hacer dos más ejemplos. Dos más.
You have 2 more.
Sí. 2 more examples. Next one. What I'm trying to do is give you good enough examples here so that when we get to work on our assignment, I feel like obviously you're still going to have some questions, but I'm trying to get enough of it covered that you are empowered to kick some booty. Did your mom explain to you that it only works with a linear divisor? Nice. Your mom must be a math person, I would say.
My parents do not. Well, actually, my dad's probably a target.
You would look at this and think, why is this the 6th example when it actually looks like we just took a step backwards? But this example does have something that I want you to see. You don't see it yet because you think like, whoa, I thought he'd give me missing terms. Just wait for it, okay? So let's start by staggering out our numbers. There's no trickery here. They are 2, 8, -5, -22, -15, and outside our upside down division house, we put a -4. So come along with me for the journey here and you'll see why this example exists. When I drop the 2, I get 2. When I multiply, I get -8. And that 0 is what makes you go, whoa. Just carry on. Carry on. Let's keep it good. So what's -4 times 0? It's a stick of 0 right here. Add them together. What do you get? You get -5. Multiply. What do you get? You get +20. Add those together. What do you get? -2. Multiply. What do you get? +8. Add them together. What do you get? Box it up. That's your remainder. Now, in the same way that when we give you problems that have missing terms, we ask you to put zeros in. We also would ask you to take them back out when they're no longer needed. Your Honor, Exhibit A. So like that 0 that you see in your answer in the bottom does not need to be there and it should not be there. So when I go to write my answer, I'm going to start by writing 2x to the 1 less than it started as, right? It started as a 4, I drop it to 3. This term that I'm vandalizing right here, he tried to be my x squared. We don't put anything. We jump right past him and go to -5x minus 2.
And it's, oh wait, and it's plus -7 over x plus 4.
Yes. And if you think now, Mr. Ahern, please shut up. We get it. I promise you from working on this today, there's one more thing that I have to show you, and then I will shut up. And you will keep that phone put away, and then I will be done, and you may get to work. All right? All right, let's do this. Last one. Let me ask you a question as you get this copied into your notes. Does the dividend, the first one, have any missing terms?
Yeah.
Where is the missing term? It's at the end. And sometimes people think that that one shouldn't matter because it's like the problem's like over, right? It's not so much a hole in the problem as it is like, hey, it's just over. You need to add a 0 at the end. If you don't, you will miss these exactly half the time. So let's do it. When we stack our numbers across the top, what are they? 3, 20, -6, 0. Right? And again, if you're going to ask why, my answer is because it would finish properly with a +0. So we bridge that gap. And then we upside down division house it, and what goes on the outside? And the process begins again. Let's go. Ready? Drop it. 3. What do we get first? Negative 18. Add them together. What do you get? Multiply. What do you get? Negative 12. Add them together. What do you get? Negative 18. Multiply it. You get 108. Add them together. 108 is the remainder.
Are big remainders like that?
Big remainders like this are actually not common. And the reason this one came out this way is because Delta Math, when I got these examples, I stole them out of Delta Math. I did not like this example. So my changing a number changed the remainder drastically. My Algebra 2 kids have been working on this. And what they're finding is if you get a remainder of like 362, you probably did something wrong. 108 is like, that's even getting outside of bounds. So you'll see. Anyways, what's the answer? 3x squared plus 2x minus 18 plus a fraction, and the fraction has 108 on top and on bottom. All right. So what I want you to do now is crack open those Chromebooks and get on to your next Delta Math assignment. And you must, of course, have paper and pencil out. These are paper pencil problems. PPP. Paper pencil problems. Nice. Enjoyable, isn't it? Yeah. You might find yourself on a boring Friday evening at home just going, you know what, I'm going to do some synthetic division.
Really?
Your friends are going to send you like Insta tweets and like be like, hey, get on Snapgram or send me a Be Real. And you'll be like, no, I'm busy. I'm synthetically dividing polynomials. I'll get with you later.